Assalamualaikum and salam sejahtera to my fellow panels. My name is AISHAH and I will be presenting on my final year project titled Computational Fluid Dynamics Simulation of Discharge Capacity at Setapak Jaya Water Gate of Rancangan Tebatan Banjir Sungai Bunus. As of today, we will be going through these agendas. Firstly, I will give a brief summary and background of the project. Secondly, I will go through the literature review on the topic. Thirdly, I will guide you through the problem statement, scope and limitations. Fourth, I'll be talking about the methodology or the methods used for this project. Lastly, I will be summarizing the presentation with the expected results and status of the project using Gantt chart. The objective of the project is to be able to simulate the water discharge rate and flow velocities according to the standard operating procedures set by the Department of Irrigation and Drainage Malaysia according to the Rancangan Tebatan Banjir Sungai Bunus project. The project also aims to investigate the effects of surface waves such as wind speed up to the flow of velocity of the discharge rate. Our goal is to also observe the effectiveness of the pump installed at the water gates, whether it can sustain the capacity of the retention pond during heavy rain. And most importantly is to achieve this objective and goals using computational fluid dynamics simulation or CFD simulation. A little background of this study has three main factors I would like to highlight that influences the need for this research. Firstly, the environmental factors. It is known that Malaysia is located on the equator of the earth where our country often receives monsoon and heavy rain on a yearly basis. Moreover, our tropical country is made to withstand such season and weather. However, due to development of high-rise buildings and houses, forested land has decreased dramatically throughout the years, which leads to runoff and peak flow. The absence of forests has made our country unable to withstand heavy rainfall, which leads to this running water to seep into city centres and rivers such as Klang River and Gombak River, which causes flood in areas such as Kampung Baru and Masjid Jamek. Furthermore, as development continues to increase and so are floods, the Department of Drainage and Irrigation or DID has initiated a project called Rancangan Tebatan Banjir RTB. RTB is a flood mitigation project that branches into 4 gates from the Klang River and mitigates the heavy rainfall into retention ponds. Recently, RTB has installed 4 10 meter cubic per second pumps to pump the waters out of the ponds to be mitigated. The success of the project was visualized during the early phase of the project. It has managed to reduce the number of affected areas from 28 to 10. However, as years goes by, Malaysian weather has been more and more tragic, especially during the latest case in parts of Shah Alam. This shows that RTB has not been 100% successful to mitigate these waters into retention ponds, or the rainfall was beyond the capacity of the retention ponds and the installed pumps. Thus, the purpose of the research is to evaluate the discharge rate and the flow velocity with respect to variation of surface wave around the Setapak Jaya catchment area. The literature review explains a little bit about the understanding and definition of the key points of this research. Flood is defined as the rising and overflowing water onto dry land which inundated or overwhelms the area. Flood Mitigation Project or RTB is a project that aims to divert the overflowing of water to its catchment area. Computational Fluid Dynamics or CFD is a software used to analyze real-time situation via simulation. Open channel flow can be expressed as a conduit which allows water or liquids to flow with a free open surface such as streams, rivers and ponds. Next, boundary condition is the numerical value as to describe the flow domain. In this case, it could be walls of the pond, water gate, and wire. Lastly, numerical value can be explained as a method to describe, analyze, and evaluate the simulation generated. The equation that is used for this open channel flow of retention pond is continuity equation and Navier-Stokes equation. Continuity equation is usually used to analyze uniform flow. It is derived as a mass that is conserved in fluid flow systems regardless of the direction of the flow or complexity of the source of the flow, such as pipeline. The Navier-Stokes equation is to describe the velocity, the pressure, the density of a moving fluid flow and are related. The equation is an extension of Euler equations, which talks about how viscosity affects the flow. The problem statement of this project is the overflowing of water from Setapak Jaya Pond. The heavy rainfall is beyond Setapak Jaya's pond capacity to hold a large amount of water. Thus, at times it will overflow from the gates and the banks of the river into Klang Valley. There are 4 steps of methodology used for FYP1 and FYP2. During FYP1, we have done research on the project title using Google Scholar and news articles to collect information for the topic. By using the information gathered, we have analyzed the problems that arise and cause the purpose of the research. Lastly, for FYP1, we will generate those information using CFD software called ANSYS. During generation, I have used Katia V5 to design the model of Setapak Jaya Pond using the parameters in Google Earth. The size obtained is similar to the real-time size of the pond. The pond was then extruded into the depth of the pond at 4.3 meters deep. It was saved as IGS and imported into ANSYS. In ANSYS, the model is then meshed into a maximum size of 5.0 meters and element size of 50 meters, and the result is as shown. Lastly, the area of the pond, according to a research done by Nurhayati binti is 56,000 meters square. Setapak Jaya catchment area can store up to 228,490,000 meter cubic of rainwater with negligible external factors such as sediments. Thus, we expected to find the discharge rate of the water is higher than the pumping capacity of the pumps installed. The project status are as shown for FYP1 and FYP2. It is expected that the project and FYP2 will finish on June 2022. Thank you so much for your time. Have a nice day and stay safe.